Okay, guys, I'm at home recording this test review because I forgot to record today in class, so I can't promise you what you're going to hear. Alright, today was March 30th. We have a test. See, there you go. Courtesy of Mr. Salling. We have a test tomorrow, 11-7 and 11-8. 11-7 dealt with area and perimeter ratios. Remember that a scale factor is comparing two similar objects. And when you are comparing them, you need to compare corresponding parts. If you were talking about circles, you would compare radius of one to a radius of another, or the diameter of one to the diameter of another. If you're talking about a right triangle, you could compare hypotenuse to hypotenuse, etc., etc. The perimeter ratio, since we're simply adding linear measurements, is also the same as the scale factor. And the area ratio, since it's two-dimensional, you simply square both parts of the scale factor. And remember that we always express ratios in lowest terms. On page 458, there is a chart. Be able to fill in that chart. You will have one like it on your test. I also liked this question on the homework assignment, so let's make sure we're familiar with it. In this circle, you have you have four chords, two chords crossing each other in the center and forming two triangles. If you were asked to name two similar triangles, you've got to start by identifying the angles that would be corresponding to each other. So, if we start with triangle ABE and say that it is similar, and I don't know where the little thing is, so I'll just say is similar, to the other triangle, we need to make sure we get the correct angles together. Well, if you will notice, let's see if I have like a little orky thing. I'll just use this. If you will notice, angle A is an inscribed angle which forms arc BC. Is there another inscribed angle forming arc BC? Yes, Miss Salling, angle D. Very good, Miss Salling. Angle D is also forming arc BC, and as from the circle chapter, we learned that two inscribed angles intercepting the same arc are congruent to each other. If you look at angle B, it is an inscribed angle intercepting arc AD. Do you see another arc intercepting arc AD? Yes, I do. It's right here. It's angle C. And then we have angle E that equals itself because it is a vertical angle. So, ABE is similar to DCE. Now the next question would be, what's the scale factor? Well, you can't just randomly line stuff up. You got to make sure everything's corresponding. If we look in the lower triangle, the only side we know is CE. So, we are going to try to decide what the corresponding side is in the other triangle, and that would be BE, which we know its measure as 6. So, the scale factor of these two similar triangles is 6 to 5, which means that the perimeter ratio is exactly the same. It is also 6 to 5, and the area ratio is found by squaring both of these numbers, so it's 36 to 25. Now, the final question that is asked is find the measure of segment DE, which is labeled here as X. Well, from our circle chapter, we learned that if two chords are crossing each other in the center of a circle, you can find the measure of the segments created by multiplying the pieces together and setting them equal. So, you may be saying, huh, what? What you said? This is what I said. 8 times 5 is equal to 6 times x. And when you solve that equation, you get 40 equals 6x. Divide both sides by 6, reduce, and you have 20 over 3, or 6, and hold on while I get my fraction. 2/3. All right. I like that one. Let's be ready. Katie, hush. Okay, thank you. Go eat your biscuit somewhere else. I can hear you going. Okay, go.
I just do this.
So that's being recorded?
Yeah. Okay,
I'm
go. Go. Go.
Katie, Papa Center records. Katie.
Okay. I liked this question also. Same as the last. We need to identify two similar triangles. And we're going to be looking at the large triangles. So if we start with triangle AEC and say it is similar to another triangle, we've got to identify angles that are equal. Well, the first thing we see is that angle A equals itself because of the reflexive property. Angle D is an inscribed angle intercepting arc BE, and angle C is another inscribed angle intercepting arc BE, which means those two angles would be equal to each other. Angle E is an inscribed arc intercepting, is an inscribed angle intercepting arc EC and angle, well, no, never mind. I'm sorry. That's just the third angle of a triangle. They have to be equal to each other. Duh. Okay, so how would we write that? Triangle AEC is similar to triangle ABD. All right, knowing that, the next question is, what is the scale factor of these two things? Well, for the scale factor, we need to identify parts that we know. If you look at AB, its corresponding side is AE, and we know both of those. So our scale factor, going in the order of the triangles, triangle AEC is 10 to 9, which means my perimeter ratio is also 10 to 9, and my area ratio would be 100 to 81. Then finally, we would need to find the value of x, which is the measure of ED. And again, from our circle chapter, we had that if two secants are crossing or making an angle outside of a circle, you can find measures of the lengths created by multiplying the external portion of one times the entire thing. So 11 times 11 plus 9. And that will be equal to the external portion of the other multiplied by the entire thing, which would be 10 times 10 plus x. All right. Solving this equation, 11 times 20 is 220. Distributing the 10 here, I've got 100 plus 10x. Subtracting 100 from both sides, 120 is equal to 10x. And finally, dividing both sides by 10, x is equal to 12. Okay. Like that one too. On pages 458 through 459, some other problems I find interesting are numbers 9, 11, and 16. Be familiar with solving them. The next section that our test is covering is on geometric probability.